Good morning, everyone. How's everybody doing today?
Not bad.
Not bad. She's not bad. So what can I help you with today? What do you need?
What about the test?
What about the test?
What can we do to study for the test?
Well, let's see. Let's see. Under, I think it's week 3, you should have a test
Already did
review
that.
down
Okay.
here. Then yeah, that's a good place to start. Other
Anything
than that,
else?
go through those homeworks and go through that test, that test review. But other than that, if you've gone through those and you're pretty comfortable with those, you should be in good shape.
Do you have a pre-test or anything?
Just that review.
Okay.
That's what? That's Wednesday and Thursday, right? Yeah.
So just trying to remember, are we printing out the test and then doing it on video, or are we is it online, or how are we doing it?
So let's see, under mine, you can, I've got this test one. It's you can see it on mine, but it'll open up on the 14th, and you'll go into it, and you'll go into the student preview. I don't want to click on those because you'll see them, but if you do, you'll get questions. It'll look a lot like a homework. It'll just be the formatting is basically the same. There'll be places to put in comments if you want. One of the things that I will have you guys do is have some scratch paper, so you guys can write down anything that you are working on, and then there'll be a link after the test. Again, this will pop up this Wednesday. It'll pop up there, the test and the scratch paper thing, and then you can add the scratch paper in the same way you add labs, so I can see what you've done. That's particularly helpful for partial credit on things. But the test itself will just be essentially look like modified homework.
Are we allowed to use a calculator for the homework?
Oh, absolutely. And the test. Absolutely. Yes. Anything else? And I'll send you guys out an announcement when the test opens, just to make sure you all see it, and a reminder. So.
Could you also add the instructions just to make sure with it?
Absolutely.
Thank you.
Are you gonna have like a video or something about the class that we missed the last time that you're having issues?
Let's see. I sent out. Oops, just close that. I want that. I sent out. some stuff on 3.4 and 3.5. And that mostly went through kind of the 5-number summary, interquartile range, and the distinction between the 1.5 interquartile range and the 2 standard deviation rules for outliers. So, and that's what we were mostly going to talk about on that day. That's the homework that's you guys have had a while for, but that's due on the 15th. Do make sure you have that done before you take your test, of course. But if there's anything from that material that you want to look at or talk about, then let me know. I did have a problem here if you guys want to play with for over there for finding from a data set, from a fairly straightforward data set, your mins and your quartiles, because there are some issues. That video talked about finding the quartiles for even data sets, which can sometimes be a little strange. So, Brittany, does that answer that question?
Yeah, thank you.
Sure. And if there is something else that you'd like to see, let me know, and I can make something else.
Okay.
So I want you guys to take a couple of minutes. I'll give you, let's say, 4 minutes, and you can go through and find your 5-number summary and identify all your interquartile range for that data set, just to make sure we're all happy. I'll give you a couple minutes to do that. And if there's something else you'd like to look at after that, throw it up in the chat, let me know, and we can go through it. Okay, so let's talk through this real quick. First thing was to identify that median. This is a particularly nice data set because there are 11 data points. So that means we do have that one data point in the middle. That one data point in the middle separates us into a lower half and an upper half. As I mentioned in that other video, because this is a data set that we have that one single value, when we figure out the medians of the lower and upper data set to figure out the first and third quartile, we exclude that 8. So because that, imagine if we included that 8 in the lower set, then our two sets wouldn't be the same size. If we included it in the upper set, our sets wouldn't be the same size. So we remove that value so that we have 5 and 5 in both our lower and upper set. When it's an even number of data, like it was in the one on the homework and in the other video, when we're having to add them together and divide by 2 to find that median, then we can break it into 2 halves without having to exclude anything. So we do. That breaks us into a 5-number lower set and a 5-number upper set, which again, 5 numbers is nice because it's odd. So we can pick out that 3 and 16 as our quartiles. So we can get those by finding the median and then finding the median of the 2 resulting halves. Now, before finding this minimum and maximum, we can, it's nice to find our range and interquartile range. We could put the 0 and the 19 in there for minimum and maximum, as long as we remember that we might have to change that if something is an outlier. Remember, this minimum and maximum are really the minimum non-outlier and maximum non-outlier. So how do we figure out, given all this positional data, how do we figure out outliers? Well, we figure out that interquartile range, that difference between the third and first quartile. Multiply that by 1.5. That gives us this 19.5. Add that to our Q3, get our 35.5, and subtract it from our Q1, should be 3 minus the 19.5, which is what, negative 16.5. So if there's anything above the 35.5 or below the negative 16.5, it's an outlier. There's nothing even close to that in our data set. So no outliers, so that minimum can be our minimum and the maximum can be our maximum.
I just want to make sure I'm following along okay. I have one question, if that's all right. So with the 1.5 times the first quartile, is that, where do you get that 1.5 from? I'm just a little curious.
That 1.5 is essentially a convention. Essentially, if you remember kind of your box plots, if we have our median in there and our Q1 and Q2, and Q3, the question is, how far out do we want to look before we start considering things to be outliers? That distance in between the first and third of that interquartile range, essentially, if we just looked out another interquartile range distance, that's not in scale terribly far. There's a lot of data that's within one interquartile range of Q3 in either direction. So we don't want that to be our threshold for outlier, because that would make a lot of things outliers that we might not want to be outliers. So instead of just using the interquartile range, we go further, we go 1.5 times the interquartile range before we start calling anything outliers. So the nice thing is it's always 1.5. That's our tool for considering something to be an outlier. It does give us a little bit more kind of robust distance out, a little more space. So it's always going to be 1.5.
That
But-
makes so much more sense. Thank you. I appreciate
Sure.
it.
And it kind of makes it line up if you're comparing data to standard deviations, it kind of makes it line up between the 2 and 3 standard deviations. Not always, it depends on the data, but it makes the idea of outlier from the positional data match a lot better with the idea of outlier from of value data. But yeah, for our purposes, it's always 1.5 because that's the tool. Anything else from all that? Christy, if you're looking at problems that are good to practice and make sure we're happy with for the test, one of the problems, I mentioned this problem before, but one of the things I like to remind people of is being careful with our frequency tables. So for example, let's give ourselves some data here. Let's say 2, 0, 3s, 4s, 5s, let's go with that. And some frequencies here. How about 6, 10, 9, and 4? So given this data on whatever this data happens to be, 2 through 5, that might be, the number of cats people have, whatever this data happens to be. If we're asked to find the mean, median, and mode of that data set, sometimes it occurring in a frequency table can throw people off. So given that frequency table, try to decide what you would do to find your mean, median, and mode. And I'll give you a couple minutes to do that. I'm just kind of looking over the test to try to see anything that might throw people off. I do recommend looking back at that question with the kittens and the tacos.
How do you find the mode again?
So do you remember what mode stood for?
No.
That's okay. Mode that's the one we use least often.
Yeah.
It is the most common value. So, Britt, I want to ask you a question. Your 5.375. Your data here are 2s, 3s, 4s, and 5s, right?
Yeah.
So we got a bunch of 2s, a bunch of 3s, a bunch of 4s, a bunch of 5s, 3s, 2s, 5s, 4s, in a big pile. How many are in that pile? Well, that's what the frequency tells us, right?
I did it wrong.
Yeah, if these, and here's just kind of like, here's how we can kind of tell. These 2s, 3s, 4s, and 5s, having that average be more than 5 should seem like a problem, right?
Yeah.
The 3.3, oh, that's between the 4s and 5s, so that doesn't seem unreasonable between the 3s and 4s. So that's seeming a little bit more numerically reasonable. Fair? Because remember, even though we see, a 10 and a 9, those 10s and 9s aren't actually any of our data, right? Those are just telling us how much data we have. So, sorry about the dog. The dog eats some people. So if we're trying to add all of these up, because, to find our mean, we're supposed to find the sum of our data and divide by how many we have. We're adding up the 2s, 3s, 4s, and 5s, but how many 2s have we got to add together?
6.
We got to add 6 of them. So we could do 2 plus 2 plus, we could literally write down that sum.
Can you multiply them?
But absolutely, multiplying them is a lot, nicer. It's what that means to multiply, right?
Yeah.
And then how many 3s do we have?
10.
How many 4s do we have?
9.
Yep. And how many 5s do we have?
4.
So we're going to add those up and divide by how many we have. How many values are on this table?
29.
29. Yeah, that's sum of the frequencies. Add those together. That 29 is how many values we have in our big pile. So that's going to be divided by 29. So 12 plus 30 plus 36 plus 20 divided by 29, what, 60, 70, 80, 90?
98.
Divided by 29, which I certainly believe is the 3.38. That sounds reasonable.
Yeah.
So 3.38. So just knowing, the mean is add them up and divide by how many is great, but we got to make sure we're comfortable reading that information from a frequency table so we know what we're adding up and know how many we're dividing. Does that seem reasonable?
Yeah.
When we try to find that median is the one that occurs in the center. But again, it's the center of these 29 values. So sometimes figuring out exactly where that is, it can be a little tough. One of the nice tricks, if you want to find your center by position, take your number of data points, add 1, divide by 2. In this case, that's going to be 29 plus 1 divided by 2 is 30 divided by 2 is 15. That means that 15th data point is the one in the middle. So that n plus 1 divided by 2 tells you where that middle is. So the first 6 of them are 2s, and then there's 10 3s. So that 15th data point is going to be one of those 3s. So our median, or second quartile, median, same thing, is the 15th data point. It's one of those 3s. saves you the trouble of having to list out all the threes. It's a lot of listing. So this is a nice tool for finding for finding medians. And mode, most common data point. Nice thing about mode on a frequency table, it's comparatively quick. Yes, ma'am.
So I found the median in the calculator, but I wanted to understand the formula you did. I didn't understand after 15 plus 1. And so
Oh, that's
what
not
does
15 plus 1. That's 15th. That's a pH. So I'm saying the 15th data point.
Oh, okay. And then how did you figure out the 3 by the 15?
So the first 6 of them are 2s, right? So the first 6 of our values are all 2s. And then the next 10 are 3s. So by the time we're done with the list of 3s, we're at our 16th data point. So the
Oh, I
15th
see.
one has to be before that, one of those 3s.
Right. Thank you.
And mostly, again, that saves us from having to write all this out. If you're doing it on the calculator, putting in, all those 2s and all those 3s in the calculator can be a pain. If you're used to using the frequency tool on your calculator, you can do that with the 2 and the 6, the 3 and the 10. But again, having just some of those hand tools can be nice and quick, nice and quick.
Right. Thank you.
Sure. Summer?
Is it okay to use Excel like a calculator?
Yeah, absolutely.
Like it's really easy to just pump those right into Excel and then they'll organize them for you. And it's like a really good calculator. Is that okay to use?
Yep, as long as you're comfortable
Okay.
with the, with the tools. And again, here, putting those 2 columns in Excel and saying, find me the average, you got to know what to highlight, what to pull,
Yeah.
So you've got to know what the frequency table is telling you to be able to do any of those things. So however you want to go about doing this, as long as you're pulling the information from the frequency table correctly, it's all good. I will tend to look at hand tools because I think they show us the most about why things work. But for, if you're comfortable with those calculator tools, yeah, or those computer tools, great. So that mode, it's the most common value. Frequency tables are really nice for modes. The one that comes up most common is that 3 comes up 10 times. The 4 only comes up 9 times. So that's also a nice 3. So yeah, as I said, most of this comes down to effectively reading frequency tables. Questions about any of that?
I had a question. Not really to do with that, but it's some everyone keep hearing the kitty taco question from the homework. I don't know if maybe can you just give a refresher of what that question is about or something?
That question gave you a histogram of, depending on the values, depended on, your particular version. But it might have said, for, the tacos, each order of tacos you had, this many ordered 1 taco, this many ordered 2 tacos, this many ordered 3 tacos, this many ordered 4 tacos, 5 tacos, and 6 tacos respectively. So if we knew the heights of all of these, and let's say this one was at 5 people, 8 people, 10, 7, 6, and 4. So that's the scale over here. And these are number of tacos per order. The questions were like, how many orders had at least 2 tacos? Or how many orders had at most 3 tacos? So being able to kind of read the histogram to get that out, and also kind of be comfortable with the at least and at most language.
Okay. So there'll be like one graph, and then you'll have like maybe a number of questions about that one histogram, or
Mhm.
like the one frequency chart, or okay.
And just for the fun of it, since we're here, how many, according to this histogram, how many had at least 2 tacos?
13.
13. Well, at least 2 tacos.
Oh, no.
You got to go the other way, right?
Yeah.
Yeah, at least. And again, that's one of the things that make that language ugly. When we think of least, we think of less than. But least is what the lower bound is. So the lower bound is 2 tacos. At least 2
35.
tacos is 2 or more. So it's going to be all those 8 plus those 3 plus those 7 plus those 6 plus those 4. So what, 25?
35.
35? Oh, 35. Thank you. 35. Or lots. When we talk about that, at most 3 tacos, again, we see that word most and we want to go more than, but at most means it's the upper bound. So at most means 3 or fewer. So that's going to be those 10, those 8, and those 1, and those 5.
Yep.
So that's going to be your 23.
And then do we break these down into percentages?
Not unless you're asked to.
Okay.
And if you did, it would be in terms of relative of frequency. So the total of here is what, 40 in here? So the total here is 40. So if you were asked for percentages here, you would be doing the 35 out of 40 and the 23 out of 40. And you'd want to be careful about mixing that with our empirical rule questions. Because we don't have the mean and standard deviation here, these breaks aren't mean and standard deviation breaks. So the empirical rule, the whole 68%, 95%, doesn't apply here. So careful about that. Not sure if that's what you were asking when you were thinking about percentages, but that's certainly a danger. Your mic's off, actually.
Oh, I didn't realize that. Yes, that's exactly. It's hard to not get those mixed up. The empirical rule when you see the histogram like that sometimes with is. Okay.
Now, we could do that, but we'd have to figure out what the mean is. We'd have to figure out what the standard deviation is. We'd have to build that.
Yeah. Okay. That makes sense.
But speaking of those questions, let's say given, let's go with scores on a test with a max score of 200. There was an average. And I gotta tell you which average, a mean average. Or let's say 140 with a standard deviation of 20. And then we could ask some nice percentage questions. I'm going to add here, assume normal distribution. That's kind of the assumption we're going with this empirical rule. We'll deal with normal distributions later, like what to do if it's not later. But all of your empirical rule tools are based on normal distribution, that nice bell-shaped curve. Let's say what percentage of scores are between, oh, let's say 100 and 160. What proportion of scores are lower than, okay. So as of now, you could really be asked any multiple of 20, any strict multiples of that standard deviation, up or down from that 140, we could be asked and be expected to give percentages for. It's not until chapter 7 where we can dive into partial standard deviations, where we can go, what if it's, 2.5 standard deviations or a third of a standard deviation. Right now, we're just getting used to this idea, so it would always be even standard deviation counts, but we will get a lot more specific later. Ooh, speaking of which, I have a third question here. Find the z-score for. This could be any value. Let's say 132. So those are all reasonable test questions that might throw people off. So. I'll give you a couple minutes.
How did you find the z-score? How do you do that?
Do you remember what these Z-score represents?
No.
It represents the number of standard deviations
Oh,
your value is
okay.
from the mean. So
Okay.
see if that helps. So like this 160 is one standard deviation above the mean. So its a Z-score would be 1. 120 is one standard deviation below the mean. So its Z-score would be -1.
When you ask proportions, is the percentage?
The proportion would be the percentage in decimal notation. So for example, if say you had 35%, that's the percentage. 0.35 we'd say is the proportion. So it's just a notational difference.
How do we start with the proportion of score? Like, what's the first step in number 2? Is that the imperial rule part?
Yes. And
Okay.
for both of them, I would really start with your diagram. So we've got the empirical rule is the 68, 95, 99.7 rules for 1 standard deviation, 2 standard deviations, or 3 standard deviations. But you might remember we went in and got a little more particular here. We went in and found the percentages for each of these kind of 6 blocks, right? These were each 34%. These were each 13.5%. And these little pieces here, remember how big those were?
So do you just guess where the 120 is on there? Or are you supposed to know exactly?
Exactly, because, well, not exactly like in the drawing, but you know that the 120 is exactly 1 standard deviation below the mean. Because our standard deviation is 20.
That.
Fair?
How do you know that 120 is exactly 1 standard deviation below the mean?
Because our mean is 140, and we're told our standard deviation is 20.
Oh, okay. Okay, that makes sense.
Cool.
So if that means that's 120, then all the rest are going to be the same class size. So then you know your whole
Yes.
graph.
Yep.
Okay, that makes sense. Okay.
So if we want to know what percentage of scores are between this 120 and the 160, if we've got this diagram either drawn out or understood, and really draw it out. It's a good thing to draw it out. Between 100 and 160 is going to include all of these values.
Yeah.
So that's going to be that sum. So the 68 plus 13.5. So we could even add the 34 and 34 and 13.5 if you want to, or just the 68 plus the 13.5. Either way, we'd get what, 81.5%?
Yep.
So 85.1% of the scores were between 100 and 160.
34. Wait, what numbers did you add to get? I got
Added
80.
this 34, that
Yeah.
34, and this 13.5.
What about the 2.5?
Well, the 2.5, oh, the 2.35 is
Yeah.
below 100. That's between 100 and 80. And we were asked to stop at 100.
What proportion of scores are better than 120? Am I? Sorry, I'm on
You're
number
looking
2.
at number 2.
Okay, never mind. I'm so sorry.
No problem.
Okay.
But speaking of number 2, if we look at number 2, what scores are lower than 120? That's going to be 120 and down, right?
16.
So that's going to be that 13.5 plus the 2.35 plus that little tiny bit in the tail there. How much is in that little tail? What?
0.15.
15.
Yeah, 0.15, 0.15, 15 100ths if you want. So that's going to be what, 0.16?
Yeah.
Now, this was asked to be written as a proportion, so 0.16. You could also, by the way, have said, well, that's half 0.5 minus this piece, so minus the 0.34. So 50% minus the 0.34 is also going to give you the 0.16. So you could do it that way too. Any way you want to combine these
Oh yeah. that's what I did.
pieces works just fine. The z-score, how many standard deviations are you from the mean? We actually have a nice formula for that. But if we keep this conceptualization of how many standard deviations you are from the mean, if we want to find that, we got to find first, how far are you from the mean? So we take our value and subtract our mean. So the value minus the 140. And then figure out how many standard deviations that is by dividing by, why did I use theta? Divide by your standard deviation. So divide that by our 20. So that's going to be what, negative 8/20, which is negative 2/5. So negative 0.4. It's negative because it's below the mean, so that should seem reasonable. It's 0.4, it's less than 1, but that 0.1, oh sorry, that 132, that's less than 1 standard deviation below the mean, so less than 1 standard deviation below the mean. we're going to use these z-scores for quite a few things later on, particularly in chapter 7. When we start trying to break this up into finer and finer pieces, those findings z-scores is one of the ways we're going to control that. So getting used to thinking in terms of z-scores is handy. Questions about any of that?
It's not about that. It's about the test on Wednesday.
Uh-huh.
Are we doing Zoom call too, or only the test?
I was going to do a Zoom call too, so you guys could ask anything that you've been working on or playing with, just to give you guys that opportunity.
So we do both on the same time?
Not at the same time. You can take that test anywhere Wednesday or Thursday.
Oh, okay.
So
Cool.
come on Wednesday with preferably a lot of good, questions, things that have been bugging you. Or if
Yeah.
you're happy, go take the test. Or you ask a couple of questions and you're good, then great, go take the test.
All right. Thank you.
Sure.
I have a quick question about the labs because I have been watching My Open Math and it just looks like they have been getting pushed back, and I just want to make sure that I'm not missing something or something shouldn't be turned in that I'm not turning in, that kind of thing.
Let's see, I think I only pushed back one of those labs, but yeah, that lab was due here, and I pushed that homework and lab back just to give you guys some time to play with it. You really should have both of those done before you do that test. But if you guys want to talk about that lab more on Wednesday, or even if you have some questions on it today, both of those things are all fine and good.
Okay, awesome. Thank you.
Yeah, I do also have a question about the lab. In the labs that I turned in, they say NA. What does that mean?
Some of them do that. I'm not sure exactly why they shouldn't. That usually means, I have it on my end. Let me check particularly. But yeah, for some people, it's coming up on your end as NA, and I'm still trying to get or hear back on why that is. But yes, I have yours. The
Elena
NA
says
did
that
stand for something. Where is it? Like not attempted or something weird. Ooh, actually, let me see if this will fix it.
Elena says that you're trying to hide the score.
What's that?
That Elena said that the NA means that the teacher is hiding the score.
Why would
So
I
you're
hide this?
trying to hide the score from us?
Why would I hide your own score from you?
I don't know.
So maybe I could change that in there then. I don't want you to know how you're doing. You might get complacent. I don't know. I got nothing. But let me look. There's a thing about when you guys can see stuff. Additional display options. Oh, that's not what I want. To ensure consistency, if you change one of these settings, you should change them all. Oh. Why would I not you want to see that? And that doesn't apply. Okay, well, that's not, that part's not working. I'll keep working on trying to figure that out. Glad to know your score wasn't so shameful it had to be hidden from you. No. Are you guys all having that NA on it? Oh, okay, that's weird. Yeah, I can figure out, I can fix that, but it'll take me a little bit more than trying to do it right now. Good to know. Yeah, if stuff like that happens or you're not seeing, particularly if it's something that you've sent me like that, if it's not showing up, let me know, because it's a weird program. So sometimes we're just not all communicating well. So between the software. So yeah, just let me know and I can usually fix just about anything, or I can tell you from my side what I see, and that's what goes in the books. So if what I see is right, then we're all good. But I want you guys to be able to see so you guys can keep up and make sure you know what's going on. So I will go in and try to figure that out. Let me make myself another note. So I'll try to figure out why that happens. Cool. Thank you for bringing that up. Anything else I can do for you guys today?
So I think someone asked that before, but I'm not sure. The lab number 3 was supposed to be due on Wednesday, but you moved to Monday 19th.
Yeah, I'm sectioning off chapter 4, and that's on chapter 4. So your exam is only going to be through chapter 3.
Oh, okay.
How
Thank you.
many questions is the exam going to be?
I believe it's 11.
Oh, cool.
How many attempts do you get for the exam?
1. That's the big thing that makes it different than the homework. And that's one of the reasons that I say, have some scratch paper, be working on scratch paper. So when the test is done, you can scan and turn in, there'll be a link for turning in that scratch paper, because then I can see what happened. And as I mentioned last week, it's very common for those, when you first see those test scores, for them to look fairly bad, but that's just because I haven't gone in and graded stuff that you write. I haven't looked at your stuff to assign partial credit. So tend to be mindful of that. Like, so the score will pop up and like ignore it for a day or two, which I know is hard.
So it's best to show as much work as possible.
Yes. Because, it's easy on these homeworks to, divide something wrong or subtract something wrong, to do the problem right, but just have it not quite line up exactly. And, if it was just up to the software, it would say no and you get nothing. But I don't want you to get nothing for that. But in this format, we've got to try to figure out a way to kind of have the best of both of those things. So, and the best way to do that is to have the computer score what it can score, and then have me get copies of your scratch work. And just to throw it out there, it's really helpful if that scratch work is organized and neat and tidy. It should be sent in. I think the guidelines we give is it should be sent in within half an hour of finishing your test, just so you're not playing with it or anything weird. I don't stress about that, but if it's like I haven't gotten it for a couple hours, I'll get nervous. So just when you're done with the test, scan it and send it off.
Do we get to use notes?
Depends on which test. The later ones have some things on notes. For the first one, you are allowed to use a calculator or Excel. And I think that's it. I will double check that, but I think that's it. But it does, I'll let you, I can send out a thing, you know, when I send out test instructions, I'll remind you of that. I'll double check for that test. But I believe on this one, actually, I can just look at it here. I believe on this one, it's just calculator or Excel. Yep, calculator and Excel. And there was a nice little question that says, I promise to be good, and responsible, and honest, and grow as a person. Okay. Anything else? If something comes up, do send me like, hey, could you make a video about this or that? I'm usually happy to do that. If not, little things that I can answer, I'll answer those. I do try to make sure this stuff is guided by what you guys are doing. So a lot of you guys looking at the homeworks and stuff, a lot of you guys are doing what you're supposed to be doing. You're working ahead so you can answer, you know, ask good questions and we can clarify stuff together. A couple of you guys are a little bit behind. Make sure you get that caught up and you let me know what you need. Okay. Okay. I'll let you guys go then, and do let me know if you need anything, and have a good day.
Thank you.
Thank you so
Thank you.
much.
Bye.
You're very welcome.
Thank you, you too.